I'm a lecturer in NTU with the physics division. So I teach students in engineering, students doing a physics major, and I also look after students doing project works. Okay, so we have an interesting making and tinkering course, and I'm looking after that. Okay, so I'll be one of the hosts for this session. So let me introduce Frederick, who's also co-hosting this session. Um, so Frederick, maybe tell us a little bit about your area of research and teaching, and when do you come to Singapore, where from?
Right, so I'm actually from mathematical sciences, so I'm a mathematician. I'm actually coming from Switzerland. I came too long ago already. My area of research is mostly, my main area is around algebra, number theory, more a pure math type of topics, which it's actually mostly what I teach as well. Though I do have quite a lot of I have quite a lot of interest in application of mathematics to different areas. So some of the application of algebras I'm looking at are into coding theory, cryptography, but I also look at other type, like broadly other type of application.
Okay, I should find out from you one of these days. Yeah, I'm also
Yeah,
interested
you should.
in cryptography. Yeah. Okay. So we'll just go around, to introduce, our alumni who has joined us for today's session. So they'll just do a very quick introduction, and then we'll ask them some questions. Okay. So let's start with Daryl.
Yep. Hi everyone, I'm Daryl. So I graduated in 2012 for my undergraduate, and then after that I did a PhD, and then I graduated again in 2017. I'm currently working as a data scientist. Yep. Look forward to share a little bit more later.
Yeah, so Daryl is from our physics program, and I think Stephen is also from our physics degree program. Stephen, you want to say a few words?
Okay, hello everyone. Hello everyone, my name is Stephen Lee. I graduated in 2011 from NTU at the School of Physical and Mathematical Sciences. I majored in physics and minor in mathematics. I'm currently the co-founder and the CTO of my own company, JobCrack, a big data and AI-driven company that helps to transform the workforce of enterprises and multinational companies. I look forward to share more in the later session.
Yeah, sounds interesting. Yeah, your job is more interesting than mine. Okay. Nelly now is my colleague. Maybe Nelly, you can introduce yourself.
So hi everyone, my name is Nelly, and I graduated from the physics department in 2012. I think I'm actually in the same cohort as Daryl. And after that, I worked as a research assistant in CQT for a couple of years before doing my PhD. I was doing my PhD in the Netherlands, working on quantum thermodynamics, and graduated in 2017, I think. Went on to do my postdoc, and only very recently joined back in NTU as assistant professor. So indeed, it's great to be back in NTU, and it's great to have Shen Yong as a colleague.
Yeah, welcome back. Okay. So we have Aaron and Chin Kok from Math. So we'll start with Aaron. Aaron is muted. Okay.
Sure. Yep. So actually, I'm a 2013 graduate. I studied mathematics and economics at NTU as well. I think on my profile on the website, I'm actually with KPISoft as a director of customer success. But most recently, I've just moved over to ByteDance, who is the company that looks after TikTok, as part of their whole monetization integrity team, looking at data as a product. So we can also talk more about that later in the discussions.
Very good. Okay, we'll see how your maths degree help you in your work. Okay, Chin Kok.
Hey, hi, my name is Chen Kok. I'm the founder of Wealth Dojo, and I'm also a $1 Million Roundtable financial consultant with AIA. So my vision is to build the biggest community of financially free families all over the world. So I realized that majority of families all around the world are overwhelmed by families and work obligations. So even though they are hardworking and educated, they are stuck financially. So my main role in my life is to really elevate them to break this trap using my strategy, this 6-level wealth karate strategy, which probably we can talk about it later as well.
Yeah, I'll buy you lunch one day and you tell me more. Okay, So let's get started. Okay. So all of you did majors in maths or physics. I'd just like to know, how do some of your skills or the content that you've picked up from your degree program or the attitudes that you acquired, maybe interacting with your professors, how does it shape you? How does it help you in your work? And if it would be good if you could give us some explicit examples. Okay, maybe we will start with Daryl.
Yeah. Yep. Thank you, Dr. Ho. As I've introduced before, I'm a data scientist, and it's branded as one of the sexiest job in the 21st century by Harvard Business Review. But I can assure you, it's nothing that sexy actually. A lot of the stuff that I do at my daily work also involves what I've learned in school, and I'm thankful that I've picked up these skills in school. Right. So I think one of the most critical skills that I've learned, especially as a physics student, right, was this ability to conceptualize a problem into like a mathematical framework, and then being able to build models around it to sort of like understand the system and try to solve it, right? And in business sense, these problems, so in the physics world, this may be physics problems, but in business world, this turns into business problems, right? So the strongest skill is really to be able to mathematize this, which the physics background has fortunately given to me. Uh, and then, of course, to apply the tools that I've used and the inspiration from nature, right, which is what physics seeks to explain, to kind of like model real world situations. So I'm very thankful that NTU, like my education in NTU, actually gave me this opportunity to learn such stuff that can be applied to what I do to put the bread on the table every day. For now, yeah.
So okay, I'm going to hang on with Daryl. So you are a data scientist. But they are also computer science students, right? So how's a physicist different from a computer science student? In being a data scientist.
Yep. I think that's a good question. If you work in a tech firm, right, most of the time there's a lot of diversity. So tech firms do hire computer science graduate as well as science graduates. So when you come together and you mingle, then there's a lot of things you learn from one another. So I would say one of the things that the physics student would be very strong with would be the ability to transform mathematics into engineering or problem solving. So it's that whole concept of what I just shared before about mathematizing, right? And you're very familiar with formulas, and the intuition behind formulas as to how they can construct models, right, would be or understanding models universally, right? It's a skill that I think the physics student and the science student would bring to the table as compared to sort of like an engineering student, right? Who will bring other sort of skills onto the table, definitely. Yeah.
Okay. So I also would add in that usually I'll force my students to learn things from first principles. So probably that worked out for you when you go to work. You probably need to understand a lot of things from first principles, and that's probably one of the strengths of a science degree program. So now I'm going to go over to Aaron from a mathematician's perspective. So how do some of these skills and content and attitudes that you picked up help you in your current job?
So I'll actually add on to what Daryl just mentioned earlier. I think one of my first few jobs once I graduated from NTU was being a management consultant with McKinsey. And over there, there was really a lot of advice that we provide to our clients in terms of how they actually approach a market sizing problem, how to actually run through their investment life cycles and stuff like that. And none of these things are done, through fluff or whatnot. It really takes on a very fact-based approach. And along the grounding that we have done in mathematics, especially through the education that NTU provided, right, allow us to kind of build a whole ton of forecasting models in a very structured manner. I think that's one of those key differences because I think a lot of my colleagues then were, people coming in from business, and the kind of insights that they bring in is very different from the very structured approach that a mathematician will bring to a table. Yeah, so I would say that that's one of the key differences and skill sets that is, kind of differentiating for me when it comes to my work.
Okay, that's interesting. So does anyone have something else to add?
Yes, Prof. Ho, I have something to add. Yes. So, for instance, in my undergrad years, I have learned to develop many computer simulations that allows me to bridge the fundamental relationship between mathematical techniques and programming logics. So some of these simulations are actually like computer games, but instead of a multiplayer, it is a zero-player game where I get to control the parameters to shape the outcome, which I'm still using it at work today. So I guess besides that, my physics education also sort of trained me to see things differently, or rather in a systematic approach. For example, given a complex project at work, I'm able to break down the problems into a manageable size and then solve them in an organized manner using some hypothesized methods. This really stands me out from the rest of the colleagues, which is very useful.
Okay, so you have all told us a little bit about what you are doing currently. So I'm wondering whether you are still in touch with some of your NTU friends, and whether you could share if you know what kind of other jobs maybe they have been working on.
Yeah, so it reminds me of something that happened a couple of years back. I was attending a conference in the States, and it was a very large conference on physics. And it was a very pleasant surprise how many of our alumni, my own friends back from undergraduate days, that I actually met there because they were doing their PhDs in different parts of the world. And we really had a very pleasant catch up. So a good number of them actually went on to pursue their PhDs and do research in physics. I know some people who are teaching currently as well in JC and in Poly. I think also quite a number of them are actually doing research related jobs in DSO and in A-star.
So teaching and research related. Chinkok?
Yeah, so for me, just like what Nelly mentioned, I'm just thinking what my friends are doing, and I realized that our degree in NTU is it's great because it's very diversified. You can really do any job that you want. So I have friends who are in teaching role. They are in primary school, secondary school, in JCs as well, and a big majority of them are in the government jobs. So it's spread across the sector. Some of them are in the LTA, some of them are in HDB. They're just everywhere. So a degree such as us give us a lot of opportunities to just find a job that you really want to do and not to constrain to just one path. So that's what I like about our degree.
So there is actually always a stereotype that says that, no, if you do a science degree, you either become a researcher or you become a teacher. So I think most of you except Nelly is actually a counterexample of this perception. So I'm just, all of you have interesting jobs. So I was just wondering whether, have you heard of, what was the most exotic job that you heard that your friends are doing that no one would dream that is related to a science degree? Yeah.
Maybe
So,
I can share some of the interesting ones I've heard. Of course, there are people who, like Steven, become startup entrepreneurs, and then I think Aaron's job is also pretty interesting, right? But I had a friend who was from my batch, who did PhD in my batch, right? And he went on to become a quant. So these are basically people who trade the stock market, but not using any one of your investment rules or stuff. So they would trade it purely based on mathematical signals and purely based on statistical signals, right? So it's a very cool, but I would guess very stressful job because you're dealing with so much money, right? And I've heard people even going to become doing their own startup in cosmetics. There was this classmate of mine. She went back to her home country to start a line of cosmetics. So I guess it's very dynamic, the skills that you learn. You are able to apply it into like the very techish, geekish work, which is the typical stereotype, as well as also very interesting work like entrepreneur. Steven can attest to that.
So maybe Steven can tell us more about your startup.
Sure, Prof. Well, as I mentioned, my startup is a very small company as of We started in 2014. We have a very major issues to settle, but I'm the one who in charge in solving the technical problem most of the time. At some point, the problem hit us where the HR space is a very unstructured sort of data space, where all the interviews and all the hiring process is very much unstructured. Therefore, we went out to scout for data to sort of give more insights to this industry. And most of the time we hit a wall because the data out there is very unstructured. And essentially we found a good data source that actually transformed our company. At that point, I guess we have to use all the knowledge that we know about data science to actually solve this problem and eventually build a product and deploy it, and then subsequently monetize it. It's a very long process, but then if you have the persistency to continue pushing through all the boundaries and all the bottlenecks, I think most of us can do it.
So is it okay? So this time I'm going to check with you whether it's okay to share what you mean by data, because we are talking to students who are in JC and Poly. So if it's not too sensitive, you can share what's the data and what is the value addedness that your company brings to the data.
When I talk about data, it's mostly, we call it labor market data. These are either job profiles data, which is like your typical resume or CV, and also the job description that is posted by the employers. So these are the two very similar data, but it comes from different parties, and matching them is a not so easy task. So to actually match them and then find the relevancy and try to also imitate the human nature in it is a lot of science involved. Data science is one, but then there's also human factors that you need to factor in, like how a HR manager will actually see a person from their CVs, and also understanding the underlying job description that the company wants to hire. So those are the challenges.
Yeah, I heard that this in the news because I think very recently there was a mention that there were like 120,000 vacancies, but there are still people who can't find jobs. So your company will be able to solve this problem.
Yeah, I mean, we are trying to help out in different angle, because this is not a very straightforward problem that one company can solve it all. It has to couple with government policies, future planning of the workforce, and also incorporate some of the economics elements in it. So yeah, we're working with government agencies to work it out to help create the skills taxonomy of the Singapore's as a national projects, and then hopefully this will benefit the subsequent generations to come.
That's good.
Okay, so maybe one way of concluding this sharing could be maybe now that you look back at at how things were, like you can look at the whole experience from deciding which degree to take, actually taking the degree, and now you can see quite some years later what you end up doing as a job. So maybe each of you could share how it all started, like what made you decide to go for a particular science degree, and with the perspective that you have now, you could maybe give some advice to students who are now in the situation to make a decision for their studies. I don't know, we can start, I don't know, maybe Aaron.
Yep, sure. So I guess my advice to students or prospective students would be, you don't actually need to know what you want. You just need to figure out what you don't want. And choosing a course like mathematics, right? Like I think when I was like evaluating my choices among all 3 universities and stuff like that, the core reason why I chose mathematics was that it opens up a lot of options upon graduation. I think if you look at like my experiences, it definitely shows the full spectrum of flexibility and adaptability, including the acceptability of a mathematical degree. And especially so that it's gathering a lot more growing interest in the whole data science, AI aspects, especially in the industry. So my key advice is, I think, don't overthink what you need to do or what you want to choose. Just go with something that's a bit more generic and something that, you know, gives up the most options as you graduate, and that will do you the best.
Okay, thank you.
Okay, maybe I can go next, and
Sure,
then
Daryl, of course.
I can nominate the next person, so that then,
Okay, sounds
because
good.
you know Aaron is actually on the left of my screen, so I will just nominate on my right after I finish. So and also because I want to echo what Aaron said, right? Basically, about choosing you know what you don't want to do, just having to be sure of what you don't want to do, right? Because I chose physics because I wanted to do physics. When I was in JC, I actually liked the subject, but it turned out to be so different from you know what I was taught in junior college, right? But I think what's more important is to really choose something that you are passionate about, something that you know you have interest in, and then along the way, like what Steve Jobs says, connect the dots, right? Because when I chose physics, it was also, you know, in terms of career options, people used to think that it would, you know, it's a very, you know, limited kind of career choices for people who study hard sciences and mathematics. But look how the data revolution has changed the way we looked at these things, right? So along the way, I guess it's all about, you know, connecting the dots, and at some point in time, you will figure out something that you are passionate doing, and then at the same time it's viable as a career, right? Or you know, and it pays the bills to start with, and maybe even do well, right? Because the next, I mean, everybody says the next you know 10 to 20 years is going to be science again, right? Just like they had said this 10 years ago. So don't be too worried, choose what you like, learn how to connect the dots between the things you like. Yeah, and then I think the person on my right is Cheng Kok, so I'm gonna nominate you to go next. You can do the favor later.
Okay, thank you very much, Daryl. So for me, I want to speak to all those people who are considering a degree in the finance section. Okay, so I will join NTU. I joined mathematics and economics is because I deliberately did not want to choose business or accounting, and I felt that economics and mathematics have an edge over. In my role right now, I felt that my degree in mathematics and economics have an edge over those people who actually studied accountancy and business, because I get to see things from a different perspective, especially from an economics perspective and also a very mathematical perspective. So those of you who are interested in finance, you can consider mathematics and economics. And if there's one advice that I want to share with you guys today, it will be just three things. Number one, be curious. So whatever you want to find out, just go search the internet, ask someone. Number two, if there is an opportunity, just step up, then eventually you'll learn something. And number three, don't be afraid to ask questions. If you have something on the top of your mind, just ask someone, because if you don't ask anything, the answer is always no. Okay, so I'll just pass on to the next person, Nelly.
Yes, thanks, Chen Kok. I think I resonate quite a bit with all the different points that Daryl, Aaron, and Chen Kok have already made. Um, about, for example, you know, knowing what you don't want and going for what you want. And I think more fundamentally, that is an outcome of reflecting on yourself. So I encourage people, before thinking about what to do, to really understand yourself, understand your likes and dislikes, understand what you are good at and what you are weak at, and make choices based on these reflections. I decided to do physics when I was 15. So way before I came to the point where I needed to make a choice. And that the reason for that was really simple, because I have always been fascinated with how nature follows certain patterns. And I know that it was hard. I know that people discourage me from studying it and say that, you should go into, I don't know, engineering instead or something else instead, because physics is hard or something like that. I never listened because I think that I'm willing to pay the price for physics being challenging. I like being challenged, and I like the process of really acquiring that type of new knowledge. And I think that personality is usually, that's the reason why I chose to do physics, and that's also the reason why I stuck to physics until right now, I would say. I don't think I can stress this more, because we are in a day and age where university tertiary education is almost a default for young people, but it's not always very clear what to study. You only know that you have to study something, but you're not sure at all what you want to study. And as a result, sometimes people can decide what to study purely based on, for example, I'm good at physics, then I study physics. I'm good at studying mathematics, then I do mathematics. But also, as previous people have echoed as well, university, what you experience in studying these subjects in university can be very different from the secondary school level. So the question is, what is the motivation or the fuel that keeps you going in spite of those challenges? And I think that really ties along with knowing what you want. Yeah. I think it's time for Stephen instead.
Well, I guess I have to wrap this up, right? Guys, can you hear me well, right? Okay, so I think Nelly made a very good point. I mean, the reason why I chose to study physics as a young kid is because I heard a lot of the atomic bombs stories from my dad. He always showed me this fascination about all these scientific sharings. But as a curious kid, I think we all want to know about what is the final questions that you cannot ask further. It's like, what kind of educations will give you the understanding of the most smallest particle, or even the biggest sort of cosmology out there. Physics is the one that can only answer that, I believe. And adding to that is that if you want to know the fundamentals of how do you interpret the physical meanings, I guess you can't run away from mathematics, in a way that mathematics is the mother of all sciences, right? You have to quantify something using mathematics. So that's why having major in physics and minor in math is a very obvious choice to me. But just a piece of advice to all the prospective students. I think education choice are the hinges of your destiny, right? And sometimes it's the smallest decision that will change your life forever. So you probably might not know what to choose, but then you just have to keep exploring. And I've chosen NTU as part of my education journey that molded to who I am today. And I think you guys can make a difference too. Yeah, and I wish you guys good luck and all the best.
Thank you very much. I believe that the audience would have lots of questions that you want to ask the panelists. So I will refer you to the Zoom session at the end of this whole sequence of talks. Okay. So thank you everyone for your time and contribution. So I'll see you later in the Zoom room. Okay. See you.